All right, folks. So if this is their first time tuning in, I'm just doing a continuation of the work I was doing last week on Forallpeople. I've got a web page up here. This gives you some background information on Forallpeople and what sort of the facets of it that are going to be important for what I'm going to do today. So the idea today is to do some updates and specifically to implement a specific feature, which is the ability to add default units to your unit environment. So a unit environment is a JSON file that covers all of the units that you would like to have in your computing space. So if we've got, let's say, a Jupyter notebook open, and we've got Forallpeople imported here, and we do import Forallpeople as SI, then we can do si.environment, and it will tell us all of the units available in our namespace right now. So in this namespace, under SI, I can access kilogram, I can access meter, etc. However, I can also import or load up a specific units environment, and so those are just the names of these JSON files without the JSON suffix. So electrical, structural are the thermal and US customer are the ones that I've gotten here, also a default one. And so if we load up, say, the default environment and then run si.environment without any arguments, then we can see all of the units available in this environment. So this would be si.hertz and si.newtons. These are all of the derived units in the SI unit system. So conversely, we also have the structural one, which is, because I'm a structural engineer, this is sort of the main one that I've been working on and that I work with. And we've got si.environment here, so we've got, similarly, we've got si.newton, just the same, but now we also have kilonewton defined, so that means I can use a kilonewton by using the symbol kilonewton, the identifier kn. Similar meganewton is available with the identifier mn. And I've also got US units in here because I am a Canadian, and so we work in both US and SI. And so the unit here, PSF, is also available. And the thing about Forallpeople that its main impetus behind it is the ability to work with units that are between sort of different unit systems. So US customer units are defined on the SI unit system, but they have an additional sort of scaling factor applied to it. And so when you say have a pound, it has the dimensions consistent with a newton, but it has an additional scaling factor that sort of differentiate it as a pound. So that scaling factor is called the factor, and this is its value as an integer rational, but as a decimal, it would look like, let's see, like that. Which is probably a lot more familiar to people who are used to using this unit system. So the feature here that we're going to add is the ability to make sure that whenever you do operations where units cancel out and say factors don't get computed quite right, or factors end up getting mangled. Say if we were to do si.pound divided by si.meter, sorry, let's do it like this, si.pound per square foot divided by si.meter divided by si.meter, we should end up with a force. And oops, I did that not quite right. No, I did it wrong. Multiplied. Duh. There we go. Times si.meter squared. There we go. We end up with a force. And but you'll see here that the units defaulted to SI units because the factor of this whole thing ended up getting mangled, and we don't have a factor in the units environment that matches it. So because no match for the factor was found, the environment looks for the dimensions, and it looks into the environment for dimensions that suit, and it sees this guy here, and then it defaults to serving it in newtons. So the idea behind this now is that it would be nice if you could say, do something like this, add another element to this environment saying default is true. And so in the event that a unit with a dimension of this is not found in the units, is found, but a factor, it has a factor that does not match anything, then it would default to this, whatever you indicate as the default unit. So in SI, using the Newton here as an example is a bad example because of course it's already the default, but let's say we're wanting to work in pounds as the default unit. So we'd say something like this. Default is true, and then that will allow this to be selected as the default instead of the SI unit. And then the factor to be sort of manually overridden and applied with this factor here. And because it's got the same dimension as whatever, you know, your resulting dimension is, it will look for the dimension first, then look for the default unit, and then apply that if there is a default unit applied. I might be wrong on the logic there, but we're going to get into that in just a sec. So I've made a bunch of changes here. I'm going to just, what I'll do is I'll just save this file, open up my GitHub desktop, and discard the changes like that, so I don't have to worry about undoing a whole bunch of times. And now let's look into the Forallpeople library and see how we would do that. Now, I wrote this a long time ago, well, not a long time ago, I suppose about 4 or 5 years ago. But I don't have sort of memory of exactly where to go. So I'm going to be sort of coming at this as though I'm an outsider, which is what I was hoping to sort of convey here. So how do you sort of jump into a library and have a feature you want to add and figure out how to add it? So it helps to have some knowledge about the library from just using it. And so from using it, you should sort of have a feel for where things are, and sort of with imports and such. Now with Forallpeople, it's a little bit different because when you import Forallpeople, it's kind of like in the top level namespace. Like there's, what I mean by that is I'm not saying from Forallpeople dot something import something. I'm just saying import Forallpeople. And if I restart the kernel here, oh, my daughter just popped in. Hi, sweetie. So if I do import Forallpeople instead of import Forallpeople as SI, now I've got everything in this Forallpeople namespace. All right, bye. All right, she's going out for a walk. All right, so we've got everything in this Forallpeople namespace now. And so one of the features you might know of Forallpeople is that it has this ability to sort of take all these units here that would normally be under the Forallpeople namespace, like that, and instead to put them in the top level namespace. Top level equals true. How this happens is a little bit of sorcery. Not really, but I don't like to talk about it because people sort of look down on it in the Python community. But it's a really, I think it's a really good way of organizing it. Anyways, so we've got now have millimeters in the top level namespace, whereas previously we did not. So everything about Forallpeople here happening in this sort of top level import implies that I should look perhaps at the init.py file. Now, because that's when you import something, the init.py file is what gets run first. Now, had I had more experience at the time that I first wrote this, I wouldn't have put everything, all the main code in the init.py file itself. But because of lack of experience, and I did that, and that was just so that I didn't have to worry about having any like import Forallpeople.physical or anything like that. At the time, I didn't know how to make it so that I could do that with Forallpeople, but I believe that I can. So, but this is to say that I started in init.py, and maybe you're used to looking at other Python libraries where there's nothing in init.py other than a bunch of imports, but then you'd look into this and go, whoa, there's a lot of stuff here. Now, it's not entirely wrong to do this, and it's completely sort of valid. It's just sort of not typical. So I ended off last stream by just sort of giving a little bit of under the hood view of Forallpeople, and one of the things that you need to know about Forallpeople is that all of the work for like figuring out and multiplying units and doing operations between units is actually kind of the easy stuff. It's not a lot of code. The hard part is actually displaying the unit to the user in the way that they're expecting to see it. So at the bottom here, if we just scroll down, we've got a bunch of these magic methods, and these control how units operate between each other with the Python built-in operators. So mul controls how the units behave when they use the asterisk operator for multiplication, add for the plus operator, subtract, etc. But the main thing here is this big method here called ReperTemplate. So Jupyter has the ability to do rich representations. There's ReperHTML, ReperMarkdown, ReperLaTeX, and then by default, if Jupyter is working with an object that has a ReperHTML method name, it's like a magic method name just for Jupyter, then it will execute whatever code is in here as opposed to the standard Python repr. Now, for the repr in Python, you typically want to have a repr that represents sort of some line of code that you could use to like recreate the object. But I decided to override that and just make it sort of a representation, sort of a human reading representation of the unit. So that's what the repr does, is it shows us a view of the object in a way that we're perhaps expecting to see it. So the ReperHTML calls ReperTemplate, ReperMarkdown calls ReperTemplate, ReperLaTeX calls ReperTemplate, the straight repr calls ReperTemplates. Everything runs off of ReperTemplate, and now all of the expensive operations all happen just in this method. The whole workhorse of Forallpeople occurs when you want to see what you've got. Just doing this. This is where all the heavy computation is. So this is going to be where we want to display our default unit, because we want to be able to display the default unit in a unit that we're expecting to see. So we want to see, say, forces in pounds as opposed to forces in newtons. So this is a clue that the repr is perhaps where we want to work. So repr all points to this ReperTemplate. So here it is, returns a string that appropriately represents the physical instance. The parameter template allows two optional values, HTML and LaTeX, which will only be utilized if the physical exists in the Jupyter and IPython environment. So we can say template to use as HTML or LaTeX. So in order for us to display the unit here, if we did not have any environment loaded, we would end up sort of seeing just the dimensions here. So let's actually, I'll just restart here. Import Forallpeople, and if I just manually built up an si.kilogram times si. Oops, I guess I have to do import Forallpeople as si, or as si. There we go. Si.kilogram times si.meter divided by si.second squared. Then I don't see this in newtons. I see it as kilogram meters per second squared. And so this is the default representation. If there's no information, then about how the user wants to see it, then Forallpeople will just display it as sort of built-up base units. So in order to get to Newton, it needs to have this environment loaded where it has to look up the dimensions of the physical instance and then see if there's any factors attached. So we have the first thing you can imagine, it accesses the external environment. Environment.units by factor and then units by dimension. So these are two dictionaries that we can just see exactly what they do. So it's environment.units by factor and units by dimension. So let's look up those. Let's see what those give us. So si.environment dot units by factor. Okay, it's a function. Let's call it. Gives us an empty dictionary. I bet you if we, I'm saying this as though I don't know how it works, but I do of course know how it works. If we give it an environment and we load an environment like this, oops, si.environment, oops, I spelled that wrong. There we go. Si.environment, and now I do si.environment.units by factor. Now I see this whole thing. So this is a dictionary here, and it's designed to be looked up by the factor, which is a a Python fraction, which is an integer ratio. And the integer ratio is used to sort of preserve as much precision as possible. So units by factor and then units by dimension. So that allows us to look at by factor. This allows us to look at by dimension. Not dimensions, dimension. So now if I've got a physical and I give it a dimension, then I should be able to find it. But look at this. There's two parts to the units by dimension. There's the derived and then there's the defined. Where is the defined? Here it is. Defined starts here. So what's the difference between derived and defined? Derived is an SI derived unit, meaning all of the units under the derived dictionary have no factor associated with it. It's not a scaling. And then everything in the defined unit is all units that are defined against the SI unit system, which are all scaled by some amount. So these all have that factor component to it. So if I wanted to look up, let's say I've got SI dot kilon, let's make a say moment, SI dot kilonewton times SI dot meter. That's my, that's my moment, kilonewton meter. And now if I wanted to look at get the dimensions of this, and then I want to look up the dimensions here. Let's look up the dimensions in the derived, since this doesn't have any factors associated with it. So there's the derived dictionary. And now I can use the dimensions to look up. There we go. So I've got two options here. I've got Newton meters and I've got joules. And so why does it choose Newton meters over joules? And I'm surprised that I've still got Newton meters in this dictionary. I would assume that joules would not be in there. Let's take a look. SI structural. Oh, I do have joules in there. So Newton meters is the one at top of the list. As of Python 3.7, dictionaries retain insertion order. So another feature to know about of any of these environments is that they will look it up in order and it will take the first one. So saying that out loud now, I'm wondering if we need to do a default sort of setting, or if we can just sort of change the order of where our unit is. But I think it will always default to the derived unit, right? So the SI unit instead of the defined unit. So I think we need to do that anyway. We still need to do this default business. But if it does because if we can't find the factor, it will default to the derived. And if the derived's not there, it will then fall back to the kilogram meters per second squared representation. So there's sort of three layers. It'll look for a defined. If it doesn't exist, then it'll look for a derived. If that doesn't exist, then it will default to base unit, a compound base unit. Okay, so that's what this environment looks like, and that's kind of how it works. So once we look it up, then we get this information here. We get the lookup, sort of the symbol associated with it, the identifier that we have in the unit system. So that's SI.Newton meter. So that's the identifier here in Python code. There's the associated dimensions. Here's the symbol associated with it. You can see the symbol being shown here. And then there's the factor. It has no factor. It's just a fraction of 1 over 1. So that's kind of how that works. Let's go into the code again. So I'm not going to jump into it, but so you've got that in your mind now, what this is. This is going to be a central part, a central piece of what we're working with. So this is the expensive part. We need to know whether or not this is a check to determine whether or not our dimensions are parallel to each other. Because if dimensions are parallel, how would you know the difference between a kilogram meter per second squared, which is a Newton, and a Newton squared, which will have sort of kilogram squared, meter squared per second to the fourth. And so instead of just looking at me like, oh, I don't know what a kilogram squared, meter squared per second to the fourth is, I say, oh, wait a sec, let's check to see if that weird thing that we have is actually a power of one of the other units that we already have. So how would we do that? We check to see if the two vectors are parallel to each other. So if one is a scalar multiple, one vector is a scalar multiple of each other, then they're going to be parallel, and then we can find out what the scalar multiple is and basically divide one vector by the other, and that gives us, if it's 2 to 1 like that, then all of the dimensions come out to 2, and that is the expensive vector math method. Now, it's not done in NumPy. It's actually just done with a little Python library called vector tuple that I wrote. So that's where all the computation is, right there. And so we try to do it once. So we got the power and then the DIMS original. So what this gives us is we give it some dimensions and then some environment dimensions, and it would go through the dimensions of the original and the dimensions of the unit we have, check the environment, and then if there are any parallel vectors, it will return the power, which is the scalar multiple, and it will return the original dimension. So that's the two pieces of information we need to kind of carry through as well. Evaluate DIMS and factor. All right, so from this, we're going to get a symbol and a prefix Boolean, so whether it's prefixed or not. So DIMS original, factor power, environment factor, and environment by dimensions. So let's see, I think here, if this is telling us what the symbol is that we're going to be using, this seems like where we'd want to sort of figure out, have it make a decision about the default unit, right? So this is where the symbol gets generated. In other words, this is where it decides what unit to pick. So PHF, what's PHF? Go to the top. Imports. Bang, PHF, physical helper functions. Here we go. So we got physical helper functions here, and what was the one we wanted? It was PHF, oops, Control F, PHF dot underscore environment, evaluate DIMS and factor. That's what it was. All right, so let's go to the evaluate DIMS and factor. Here we are. If you don't know what this is, don't worry about it. It's not important. Here's the inputs here. DIMS original, factor, power, environment, environment by factor, and environment by dimensions. So we got a factor lookup and a dimensions lookup. So we're first going to check to see if we have a defined unit. So get units by factor. All right, so we're going to give it the factor. That's from our unit here. We're going to give it the original dimensions. And then we're going to give, meaning the unscaled one, if it were squared, if we had a unit squared, this would be just the regular unit. Then the environment by the factor dictionary lookup, and then we need to know the power here, because the power affects the prefix. But if it's not an SI system, then it's not going to have a prefix. So let's look at get units by factor first, and then get derived unit. Okay, so we check to see if there's a defined and a derived. Okay, so let's say we had SI.pounds. So it will find something here in the units by factor. It'll pull up pounds if the factor works. And then derived is the second layer check. So there's the first layer check, if it's defined, second layer is derived, and then if it's not found in the derived, then it defaults to that sort of compound thing. So we need to make sure that whatever we have is in here. And now if we've got a default that we want to display, and it's probably going to be in the defined, that we need to control that. So let's look at get units by factor here. It's like this, and type F12. That'll bring me to that function. Get units by factor. And so what is this going to do? Returns a units dict from the environment instance if the numerical value of factor is a match for a derived unit defined in the environment dimensions. Great. Okay, so what is it going to do? Fraction power. Okay. Can't remember what that's for, but I made a note to myself about what it was. Units match. Match factors. Okay. It's been a while. I don't really remember what all this stuff does. But I think it returns match factors. Let's look at match factors here. It's right below it. So looks up the dictionary. New factor. Okay. Units match. So basically it's returning what's in the dictionary. Okay. If units match is not equal dictionary, then return units match. Else, for factor units in environment units env, if absolute new factor less than new factors like tolerance, return units. Okay. So what's this about here? Right. Okay. So I'm checking to see if there is a match in case the unit just got mangled a little bit. So either way, it's a dictionary lookup. So units match is a straight match, or units is we're cycling through all the units and then checking to see if it's there or not. So either way, it's going to return a dictionary, and it returns a dictionary by default. So match factors is going to be looking like this. So if we did units by dimension, we did units by factor here. And then we don't have a derived here. They're all defined. And then moment.factor, let's make this si.kipfeet. Kip moment equals si dot kip times si dot feet. And now I've got moment dot dimensions. I might as well see it. Same dimensions. Kilogram meters per second squared. Yeah. And then factor. So now if I give it this factor, let's see what we get. Okay, so it found it because the factor is being transferred straight across. If I did something to this, like times si dot inch divided by si dot inch, or actually no, that should come out the same. But let's, if I did this, if I just did divided by si dot inch, then it will come out not as a moment but as a force. But by now yeah, it's in kilonewtons because it didn't find it. So the factor here of like kip times feet per inch is a factor that's not defined in the unit system. So that's a mangled factor. So if we put this here, same moment dot factor, we'll see that nothing is found. So that's the idea. That's what happens here. Nothing is found. Match factor is dot get. So if it's not found, then return an empty dictionary. Okay, so we either going to have a full dictionary or an empty dictionary here. So that's match factor. So whether or not we've got units here, we either have an empty dictionary or we've got a match. So tuple units match dot keys. Okay, well, if we have a match, what's the dot keys all about? So we're looking at the first thing. So dot keys, and then we're looking at the first match. I see. Okay, so if there's multiple, for some reason there's multiple in the units dictionary, this is sort of like a catch-all, just to make sure that we, only return one. Then let's see, retrieve dims, units not match, get dict, get dimension. Okay, retrieve dims. So return, ultimately we're going to return the unit match. Unit's name. All right, retrieve dims. If dims is not equal, retrieve dims. Oh, I see. Just doing a double check here to make sure that we're getting the exact right dimensions here, because since we're looking at by factor, there's no guarantee that the dimensions are going to be correct. So we're checking to make sure the dimensions are correct as well. And then if it is a correct match, then we'll do that. Okay, so this get units by factor, this is where we first find our potential match. And if it doesn't find a match, then it's going to return an empty dictionary here. Okay, so let's go back. Get units by factor, this could end up being an empty dict. Okay, could be empty dict, or I'll just say empty dict when no match. Empty dict when no match. Now, derived units. So similarly, this will end up being an empty dict when no match. And then we go into compound units. So I think where we want to look up is going to be here first. So I think what we need to do is just have like another lookup. Now, another lookup is not going to cost us a lot because dictionary lookups in Python are running constant time. So if we do a lookup by dimensions, get derived unit. So I think that's going to occur here. So get derived unit. So let's look up get derived unit here and let's see what we get. So units by factor and units by dim. So let's go to, let's do dimensions. Okay, so there's our dimensions. That comes out in as a Newton because we're in units of force. That's defined in units by dimension. So we're going to still get our thing here. Our lookup value. Spells it again. Dimensions. Oops. Oh, this did not work. Why not? Key error. Kilogram meter per second squared. Why is that the case? All right. So what's si.environment? Units by dimension. Let's run this and see what we have. Something is not as expected. Oh, right. Because we got derived and defined. I have to separate derived and defined. Okay. So derived. And then there. Okay. So there's our lookup. Okay. So when we do, okay, so when we, the lookup by dimension seems to be the key thing because that will tell us whether or not, so the units by factor, this is our backup. This is what we aspire to. Let's look up here. The derived is going to do is going to be where we check the default, I think, because it's in the derived lookup where we're going to be checking both the defined and derived dictionaries, I believe. So let's take a look at that. Get derived unit. Okay, yes, get derived. Okay, so it's doing a lookup just in the derived dict. Yep, doing a lookup just there. Okay, so how do I want to do this? Where do I want to put this in? Let's see here. I've got, where am I going to put that? Now, I'll open Studio in case there's been stuff in the chat that I missed. So I think I've got a chat window open here, but we'll just take a look. Oh, I think we're all good. Okay, so let's take a look. Any ideas, any thoughts here? What if we evaluate dims and factored, we get the derived unit, and then let's check for defaults, I suppose. Maybe we should do a separate lookup here. Dims basis multiple. Yeah, that's not a thing we need to worry about. That's its own check. So under get derived unit, I think is where we're going to want to do our lookup. So we're going to be checking the derived unit. I think we're going to have to look up both derived and defined and check to see if there is one of them that says the default. And if the defined doesn't match, then we need to look up return the symbol for the default derived. So get units by factor, derived. Okay, so this is going to return empty dict when no match. That's going to return empty dict when no match. And then this guy, so that means all we have to do is have another lookup that returns an empty dict. Or it'll return an empty dict if there's no default find, or if there's no derived unit found. There's no dimension lookup that we return to that. And so if it's going to look up both the derived and the defined, and then prioritize the one that has the default. Cool. All right. So I think this is just we're not going to add to an existing function here because that will just confuse things. And I want to make sure that any of the code we add does not break anything else. And so I think the best way of doing that is to not touch the implementation of any of this other stuff. So let's write our own new implementation here. So it's going to be def check. Let's see. Get default unit. Yeah, let's call it get default unit. Let's make that our scope. And it's going to require the dimensions. And where else are we going to need? We're going to need a units environment. And that's going to be the derived and defined. So we'll have both of them in there. So units environment, and that's a dictionary. And then it's going to return a dict. Same sort of thing as this other stuff here. Now, do I need anything else in here? I just need the dimensions to look it up. And then I need the units environment. And then I check to see if there's anything that's got a default on it. Cool. All right. Returns a units definition dict that matches dimensions. I'm just like literally reading the doc string above here and just type with it, and I'll change it when it doesn't match, when it's not the right scope. If let's see, that matches dimensions if it exists, if a match exists in the units end. Now, if it does not exist, empty dict otherwise. There you go. And so the units definition dict will be the one that is indicated to be the default unit for that dimension if it exists, if a default is defined for that dimension. Okay, So we got two dictionary lookups. So we're going to look up the derived units, the exact same as this. Okay, units env. Now I have an incorrect function signature here. Something about how this works is because I'm wanting to, oh, remember that thing I said? It's not important. It's mildly important. So this LRU cache, what it does is every time, let's say you had a data frame full of newtons, right? And you need to convert them all, or you need to display them all. Instead of like recalculating every single, like if you got a thousand rows, each showing a newton and some value in some magnitude of newtons, then instead of calculating how it's going to be displayed for every single one, I've set up this LRU cache to say, have we solved this function before for the exact same inputs? If so, you know, just return the old value, so we can just skip all this expensive computation. In order for that to work, all of these values, all these parameters here need to be hashable. They need to be immutable types. If I put in a units environment as a dictionary, it is a mutable type, and it cannot work with this LRU caching. So one way of getting around that is to put your dictionary into a function and then pass the function, and then when you're in the function, that, you know, where you're doing the work in the implementation here, just call the function, and that will return the dictionary to you. So it's like having the dictionary sort of wrapped in a function. So callable is the correct type here. Now, I believe that I'm calling here units env. So I should be when I call my default checker here, I should be passing in not the callable perhaps, but I should be passing in no, I do pass in the callable, because it looks like yes, I need to pass the callable in because this guy is going to get cached, so it needs to have a callable as an input. So it looks like I'm working not with addictive inputs, and that means this is not correct either. Get derived unit. So let's update that while we go here. So where does that get called? Get derived unit, get units by factor. They both take a callable instead of a dict. So let's update that. Okay, because now that I'm working on it, I'm like, oh, I've got a dictionary. No, I don't have a dictionary. Now, if you didn't know that, then you'd be working with this, and you'd work with this as though it's a dictionary, and you'd be like, wait a minute, why am I getting an error here? Why is it not a dictionary? It said it was a dictionary. So callable. So I'm making sure that's correct now. All right. Yeah, see, it's callable. I'm calling it here. I'm calling it here to get the dictionary. Okay, so that's correct. So get default units. Okay, so there's the derived units. I'll call it, instead of derived units, that's kind of ambiguous. Let's call it derived environment, and then the defined environment. There we go. Defined environment, derived environment. So I'm going to look up the defined environment first, because that's kind of the sort of the higher level one now. Now the thing is, I don't want to have to. Okay, I don't want to have to cycle through a whole bunch of, like, I don't want to have to iterate over a damn dictionary. Sorry for swearing. I don't want to iterate over a dictionary. But I'm realizing that even if I do have to iterate over a dictionary, like, I'm only iterating over a dictionary with the amount of units that match. So that dictionary is by default going to be small, because there's only so many ways of representing, like, a force, right? You got a newton, pound, kip, and that's kind of it. So there's 3 I can think of in this environment. Maybe there's other units, but I can't imagine they'd really get more than 6 or 10. 10 representations of the same dimension seems kind of nuts to me, but I'm sure it's possible. But I guess I'm saying is I'm working on a scale of like tens of units, not hundreds, or tens of entries, not hundreds of entries. So I think iterating over a dictionary for, you know, a scale of tens is fine. I'm not going to get too worked up over that. So I've got my derived environment, got my defined environment, and I need to now do a lookup on the dimensions. So get dims, and then if it's not found, then return empty dict. So in fact, let's call this now units. Derived match, defined match, matches, because I don't know if there's more than one. Okay, so let's cycle through the defined first. For defined match, in defined matches, that'll give me the keys. So what's in my environment here? Let's take a look. What do I get in the dictionary? Here we go. So it goes by key. All right, so then I'm looking over then the contents of the dictionary, and I'm going to be checking to see if there is a key in the inner dictionary that says default. So I need to see if the dictionary, the key is in the dictionary. The default key is in the dictionary. Okay, for defined match, let's say for identifier defined match in defined matches.items, I am going to be seeing if there's a default, if default in defined match, meaning the keys, then we're going to return the defined matches, which, okay, so let's say let's go back to my notebook here. So I might have more than one. So I'm looking for the item to return. So I'm looking for this whole thing here. So that's what I want to return. So I need to return ident defined match. And so that means I'm just returning this, a dictionary of the identifier and the defined match. There we go. So that's all I'm checking. So I mean, could I say default? Oh, I can't just look up the default key. That's one way of using it. What if instead somebody wrote an environment that had, what if somebody wrote an environment that had like default as a key everywhere, but then all of them were false, but only one was true? Okay, so I've got to check to see if default in defined match and defined match dot get default. So if it's a truthy value, then return that. So otherwise, return dict. Okay, so that's and if it doesn't return there, then we're returning a dict always. Okay, so that's the sort of the end of that. And now so we've gone through the defined matches. There's no defined match. Let's say you set up kilonewton to be your default. So you're never returning something in newtons, you're always returning something in kilonewtons. So now we can go through the defined, the derived dictionary and do the exact same thing. Now, this is an example of repeating myself. Now I could write a little subfunction to run this loop for me. But I feel like for what we're repeating here, I think it kind of goes with the flow of sort of the thought process. Check the defined first, then the derived. And let's actually put this in the order of that we're doing it. Defined, derived. It sort of mentally makes sense to me. First we get the defined and the derived. We check the defined, we then check the derived. So derived match and derived matches. Does that say derived? That says derived. These are all the same word. This does not say derived. Derived match. That's the same word all there. That's derived matches. That's the same word there. Defined match. That's the same word all there. Defined matches. That's the same word there. Great. Okay. So it runs through the defined first. If there's no default in the defined, it then runs through the derived. If it finds a default in the derived, returns the derived, and otherwise returns an empty dict. So I think we should be able to insert this function directly into, here, I'm going to save init.py because I didn't think I changed anything in init.py. I'll just save it and see what I did. Check out my GitHub desktop. Oh, I didn't save it. Okay, so there's nothing, there are no changes. Okay, good. Okay, physical helper functions. What did I change here? Empty dict when no match. I put in these comments here. Maybe I should take those comments out because they're not going to be helpful. Here's the main work. I got a whole bunch of white space here. So we're going to run black on this before I commit it. And here's my Forallpeople, black on Forallpeople. we go. Now let's take a look. Changes. All right. Now it's a lot sort of cleaner, easier to see where the changes are. Okay. All right, now let's take out these comments here. Empty dict when no match. Yeah, let's leave them in. Let's leave them in. Kind of as a nice shortcut for someone coming behind me. Okay, so that's, I think, enough to do a commit, but let's check this out. So before I implement this, let's write a test for it. See if it works. All right, test for all people. All right, so this is a whole pile of tests, and here's some other housekeeping I should do is take out this top level namespace business that I put in and change all these to SI dot, because it's just so much cleaner, it's so much easier to understand. But at the time that I originally wrote this, I was less experienced, and I thought this would be a good idea. I don't think it's a good idea anymore. So that's something I want to fix, but I'm not going to fix that now. So here we go. Testing of the repr methods in order of appearance in repr template. Oh, that's nice and organized. All right. Test, evaluate, dims, and factor. Okay, so this is something I'm going to have to write a test here. This will be an integration test. Integration test here, meaning that I'm not testing to see if my new function works like in isolation. I'm checking to make sure that the context within which it works comes up with the same correct result. So I'll just make a little note here that I want to write a test there. Test get units by fraction, get unit components from dims, test format symbol, test and pass through, get superscript string. I think there's test get derived unit, get dims, check dims parallel, dims quotient. Where is the one that I wrote now? Get derived unit. Let's see if there's a test for get derived unit. I'll write it underneath that. Test get derived unit. There we go. Let's write our test right under this one. And we'll write a similar style test here. So test get derived unit. I'm just going to copy this whole test, and then I'll just update it. And what are we calling it? Get derived unit, get default unit. So func is going to be called get default unit. I put func into a variable here because I didn't want to have to type phf dot underscore get derived unit the whole time in my test. Get default unit. So calls the func. Here's the dimensions I give it. There's the environment dimensions I give it, and the environment dims. Now this is defined somewhere. Where is that defined? F12 it. And vims. si.environment.units by dimension, and I've got test definitions here. So I'm going to need to write I'm going to write a default unit and test definitions. Okay, so let's try this out. And let's put a default under foot. It's true. And then where else? What am I testing here? What are the tests already doing? Let's check. Test get, oops, default unit. So I'm testing newtons and Newton meters, and let's test the length. So, because that's the case of a single dimension is a special case. So I want to make sure that it works correctly the same way. So let's say I put it foot, and there we go. This will be dimensions of 0, 0, and oops, not 0, 1. That's incorrect. 0 here, and then 1 over here. So dimensions 0, 1. Okay. Then factor is going to have the factor of the foot, which will be this guy, 1 over 0.3. Okay, so factor is test default unit is going to be equivalent to, it's going to be a fraction here. And instead of me whipping out a calculator, I'm going to just open up Jupyter and check to see what the factor is on a foot. si.foot.factor. That's it there. Okay. There we go. And so fraction is already defined in this module, so that's good. And so that should come out. All right, so that's my first test. Let's check to see if that works. I'm just gonna comment out all these guys, save this. And so now my changes are, I've got my updated on the, added some formatting here, changed some other stuff like the parameter, and now I've got my default unit, and then I got my test for default unit. Let's see if this works. Where's my terminal? There it is. Pull it open. All right. PyTest. All right. Failing test. This is good. Okay. Assert nothing equals foot dimension. So it does not find anything. Okay. So I have a feeling it's because this is a special case where it's a single unit. So dims, looking up, and it's not finding anything. So am I doing, yeah, calling default unit. Let's make sure we just did everything correctly here. Passing it environment dims. So I want to just do a confirm. I want to do, I don't have a logger installed in this here. I'm going to start using a logger. Now this is a technique I've done fairly, so I've only started using loggers recently. And but before I was doing print. So to avoid having to do a big tangent installing a logger and doing that, I'm just going to throw a print statement in here and say print, I want to see env dims equals, and I don't want to see the whole thing though. I want to see just, and this is a callable, I believe. So I need to say dot get derived or defined, and then I want to see dot get. I want to see foot. Is it reading it correctly? Okay. And then throw an equal sign at the end of that. There. Okay. Try it again. None. All right, so that's not what I expected. So it's saying give me none because it didn't find a key here. So maybe my dictionary lookup's not correct. Let's just go back and try not to do so much. Maybe I've got an incorrect assumption here. envdims.get. So it is a dictionary when I call it. That's good. So let's call defined. All right, so where's my, here we go. So I do get my defined dictionary here. And it's by dimensions. I've got foot. Yep. Symbol, fraction. Ah, look at this. Look at this. Okay, here we go. Yes. All right. So I'm finding the foot. Foot is, or rather, foot is in there, I should say. And then it's got a dictionary, yeah, associated with it. And then dimensions, the symbol, factor, and then that's the end of it. So it's not, it doesn't see the, oh, look at this, I didn't save the test definition there. Okay, so that's probably got something to do with it. So let's just rerun PyTest now and see what we have. Okay. 2 tests failed. Get default unit. Get units by factor. Ah, okay, I've got another failing test here because I'm checking to see the result here, and now I'm saying it's got a default key in there, and that key is not included, and I don't have that as part of my test result here. So I got to make sure to update that test to, it's a breaking change for my previous tests, but not a breaking change for the code because you're not supposed to be using these functions directly. So next, what's the problem here? Default equals true, and so it looks like, again, it's just the same sort of thing. So it is finding it now, but it's not got the right dictionary that I'm not checking the right thing. So it's the same problem in both places, which is that the default key is missing. So this is actually what it finds now. And so I need to check to make sure that that is the case. So now if my hypothesis is that if I run this test, I'll have now one failing test, but my test will pass, but it's apparently still failing. So let's do a check. What's the differing items? So I'm going to get rid of this print because it's just getting in the way now, because what I wanted to check is still working, or it's now working. It's not a problem. Let's run PyTest again, and now I want to see a verbose breakdown of the differing items. So what do we have here? Truncated. Let's just do the VV. PyTest-VV for verbose. And it's going to show me everything. All right, so let's see. Differing items. Symbol. Okay, it doesn't, okay, foot dimensions here. This is the first one. This is what it gets. And this is what it got. So why is it different? Dimension. Dimensions. Check. That looks the same. Factor. Fraction. 1250 by 381. Same factor. Oh, forgot the symbol. Okay, it's just a simple thing. Symbol is foot. Okay, now let's check it. One failed. Perfect. I don't need the verbose mode anymore. Okay, so what failed is the other test that is looking up a foot, but no longer doesn't have the default in there. So let's go ahead and add it in. And that is line 84. Okay, now this is specific to this particular lookup, right? So symbol foot, I think let's keep it in order of where everything is. There we go. Oops, I didn't mean to do that. Symbol foot, and then default is true. Okay. Now I should have both tests pass. One failed. Oh, what's the problem? It's probably something silly. Let's take a look. PyTest verbose mode. Okay, here's what we got. Here's what we got. It does not equal what we are expecting. So where's the default? Full diff. Yeah, I can see the default's not there, but why? I thought I just added it to the test value. This is the test value. This is what I got from calling my function. So why is it not there? Oh, am I doing the wrong one? 92? Yeah. Let's go back. What's going on here? Oh, that's why. Because it's in here twice. Now it's not number 84 that's failing because I'm looking up testing foot and foot squared in this case. I need to return this. Default is true. And am I looking up foot anywhere else? No, I don't think that's it. So now, in other words, I had a second assert fail that I didn't know about. So now let's run it. Perfect. Okay, so test worked. So the test worked for the one case. Let's try a derived. So we did a defined unit of a single dimension. Let's do another test case because this is engineering software now. It needs to work. So let's test it well. So get units. So test get default unit. Let's get back here. All right. So now let's test something else. Let's test this guy, Newton, but I don't want to look up newtons. I want to look up pounds. So is pounds in my test definition? Pound foot. Pound is. So let's just go with pound. Okay. And I want pound now to be default equals true. Now, I bet you when I add this default, it's going to break some stuff. So let's just add this and then run the test and see what tests break. Oops. When you're working with JSON, it's lowercase true. Save. Okay. So let's run this test now and just see what breaks. Nothing. Great. Let's move on. Okay. So now let's test func dims is going to be for newtons, which is pound. Great. And now we want it to return pound. And SI dimensions factor, and it's going to have a symbol is pound, and default is true. Capitalized because it's Python now. When you read the JSON into a Python dictionary, it converts all the types into Python types. Okay, so let's test that. See if it passes. One failed. Oh, fraction, the factor is wrong, of course. Let's go in again. I'm going to go right into the existing environment, si.pound.factor, and just get whatever that straight factor is. There we go. Throw that in there because that's already been tested. All right, now let's try running it. Passed. Excellent. Okay, so it looks like our feature is working so far. Let's just do one more. I want to make sure that it works with like kilonewton as well. I don't know if it'll work with kilonewton, but I kind of think it might. So let's try that. And let's do now, just copy this test case again because it's the same dimensions we're working with. And now we're going to look up kilonewton, but we can't use the same, never mind, we can't use the same dimension because we can't have two default units for the same dimension, right? So this is a good test. What happens when there is more than one? This is good. Okay. So test definitions, oops. Let's go to kilonewton up here, kilonewton, and put in default equals true. What happens? What gets returned? Oh, lowercase. Can't have a trailing comma. There we go, save it. Now, let's just leave our existing test suite and see what happens when we've got two defaults. Still, it passes. Okay, why does it pass pound? Because of course that's the order we're doing it in, right? Defined versus derived. So if it finds the defined, then it returns that. If there's no defined, then it's derived. So that's the hierarchy. It assumes that if you wanted to see it, if you went to the trouble of defining a default unit, you probably have a scaling thing that you need to overcome. So that makes sense. Now, should I have it return both? I'm going to go with no for now. And I'm going to document this behavior. So that's the key thing. I'm going to write that down so I don't forget it. How are we doing for time? Oh, 10 o'clock. We are about the end of the stream here. So where do we get? Let's finish this up and integrate it into the whole process. And let's just do the bloody commit. We haven't even done the commit yet. We've just been writing tests and implement the feature, write the test. So we've done some initial implementation. First, we're on the main branch. We don't want to be on the main branch. Create a new branch. Features. Now we're going to be doing implement. I'll say defined. I'll just call them default units. There we go. Bring my changes onto the new branch. Okay, feature. Initial implementation of default unit lookup. Added initial test, unit test. There we go. Publish the branch. That's now on GitHub. And now let's do a second commit where we just add it in and see if it's just kind of working. So get default unit is going to be called in the same area as def get derived unit. Not def, just where I call it. There we go. There we go. Now we got derived unit, and now we want the default unit. We want to know that. Default unit. I'll call it just default. We'll call it defined, derived to default. Okay. Get default unit. Takes the same stuff as everything else. Dims equals dims original. And then units env is equal to env dims. That's right. Okay. So now we have the default unit. What do we want to do with it? We need to return the symbol and the prefix bool. So we need to know if it's prefixable or not. So that we know if, here we go, if defined. Okay, how am I doing it? If derived. Okay, so this is a check. We're manually going through this process here of defined, then derived, and then units match. Okay. I want to change this heuristic, this decision tree. I don't want it to work like this. I'm saying here, no, because it doesn't check for default. I don't want to be like if defined and no default, if defined and default, if derived and default and no derived. I don't want to do that. That's crap. So what are we going to do instead? So let's say, let's do a previous, let's do a sort of a swappy thing here. Let's call this confirmed defined. No. Here's what I want to do. I want to do a separate tree first to prioritize. If defined is not there, then, and derived is not there, but if defined is there, shoot. This decision tree is a little bit more complicated. I'm not really sure exactly how I want to do this because the default could be a derived unit or it could be a defined unit. We don't know which one it is, except by checking the factor. So we can check to see if it's got a factor key, but I don't want to do, that's additional function scope. Like I don't want to do that right here. So do I have a function to check if it's a derived or a defined unit? I don't, because I'm looking them up. I'm doing like each one as a separate step. So I haven't needed to have like just like a check to see if I've got a defined or derived unit. So how am I going to do that? I could merge dictionaries. What is a good approach? I could merge the default into the defined and update the defined with the default. If the unit is the same, it's got the same key, then I will be, so no change. If the key is different, then it will be added to the end of the dictionary. Then that doesn't help me because I want to take the first one. So I think I need to sort of take a break and think about this. Okay, so I'm going to call it for this live stream here. I didn't get as far as I wanted. I wanted to just implement that and do a release, but I think what I'm going to do is I'll just leave this here and say a reminder to myself where I am. Here, you are trying to figure out how to prioritize between the defined, derived, and default units. Once this is done, this feature should be fully implemented, meaning maybe it is, maybe it's not. Okay, so I'm going to save that and I'll add my comment. Sure. Leave off comment, or rather comment sign off. Okay, that's where I'm going to leave it. And so now when I come back to work on this next week, I will know exactly where I left off and be able to just get this wrapped up, do a release, and that should take care of the scope of this Forallpeople series. After that one, then the next one on my list is section properties. I'm going to implement a feature there that has been tricky. I've been thinking about it now for a couple of weeks, and I've got an idea of how to do it. So we'll get to that in a couple of weeks. Next week, we'll wrap this up, and we'll have a nice new feature in Forallpeople that should make a real big difference for people who are working with different unit systems. And even if you just wanted to have your default units in kilonewtons all the time, as opposed to like having it sort of turn out newtons or meganewtons or whatever it is, it'll be able to allow you to do that. So until next time, have a great week.